Today on the Smart Soul Hub podcast, I'm doing something a bit different. Instead of breaking down a single research paper, I'm documenting a process. I've just completed a systematic search across 6 major research databases, nearly 3,500 records, narrowing them down to approximately 225 candidate studies. This is the foundation for a planned peer-reviewed publication on what glucose actually does to peripheral nerve tissue at the cellular level. And I want to share the methodology before the conclusions are written. This is part 6. Hi, I'm Jae Kim, podiatrist. I hold a master's in neuroscience by research. Before I was in clinic, I was studying how nerve cells die in neurodegenerative disease and developing assays in a cancer diagnostics lab. Now I use that background to do something most podiatrists don't. Go back to the primary research and ask what's actually happening at the cellular level. This is Smart Soul Hub. This is part 6 of the PIT and Dextrose evidence series. Let's get into it. So here's the background. About a year ago, I started incorporating paraneural injection therapy into my clinical practice, injecting buffered 5% dextrose solution subcutaneously around irritated peripheral nerves. In parallel, I started reading the primary research behind it. And in parallel with that, I started publishing what I was finding on this blog, parts 1 through 5 of the Dextrose evidence series. Each of those posts has been useful, but reading individual papers, even good ones, only gets you so far. At some point, I started asking a bigger question. What does the entire primary mechanistic literature actually look like when you apply systematic inclusion criteria to it? What does glucose, at the low concentrations we use clinically, actually do to a peripheral nerve cell? Not a diabetic nerve, not a systemic glucose response, a direct, acute, localized cellular response. Nobody has published a systematic synthesis of that question, so I decided to build one. The search strategy covered 4 conceptual domains: agent terms, dextrose D5W, glucose 5% dextrose; mechanism terms, Schwann cells, TRPV1, NF-kappa B, nerve growth factor, BDNF, MAPK, remyelination; outcome terms, neuropathy, nerve conduction, neuroinflammation, analgesia; and condition terms, diabetic neuropathy, carpal tunnel, perineural injection, prolotherapy. Those 4 domains were searched across 6 databases: PubMed, Embase, Web of Science, Scopus, CINAHL, and the Cochrane library. Total records retrieved before deduplication, 3,480. After importing everything into Zotero and running automated deduplication based on title, DOI, and author, 983 duplicates were removed. That left 2,497 records for abstract screening. Abstract screening was the most demanding phase. The inclusion criteria were strict: primary research only, no reviews or editorials, direct effect on nerve or glial tissue, a mechanistic outcome, not just a clinical pain score, and glucose or dextrose as the active intervention, not simply present in the background of a diabetic animal model. AI-assisted abstract screening identified approximately 225 candidate studies. I'm currently working through those manually, reviewing each one myself to verify the AI's decisions and catch any borderline calls that require domain-specific judgment. Some will be excluded at this stage. The final number, entering full text review, will be lower than 225, and I'll update the blog post when that manual pass is complete. Of the approximately 225 candidates identified so far, 133 are in vitro or cell-based studies, the basic science, and 47 are animal studies. So about 80% of the candidate literature is mechanistic basic science, which is exactly what I was hoping to find. I want to be honest about where AI helped and where it didn't. AI tools were genuinely useful in the early stages, structuring the search strategy, and processing the large volume of bibliographic data from Zotero, but applying the inclusion criteria to ambiguous abstracts, particularly distinguishing between glucose as an active intervention versus glucose as disease background, requires the kind of contextual reading that current AI tools don't do reliably enough for a publication going through peer review, hence the manual verification pass. And I want to be equally honest about what this review can and can't do once it's complete. Even a comprehensive synthesis of cellular mechanistic studies won't definitively answer what happens when I inject buffered 5% dextrose subcutaneously along a Velix point in a person with tarsal tunnel syndrome. The translational gap between an in vitro Schwann cell study and a clinical PIT injection is real and significant. What the review can do is describe the mechanistic plausibility of the treatment and identify where the evidence is strong, where it's speculative, and where it's absent. I'll post a follow-up when the manual verification is done and the final screening number is confirmed. Full text review will follow, a process I expect will take several months. The individual paper reviews on this blog will continue in parallel and will increasingly draw from papers within the candidate set. The full methodology post is at jaekim.com.au/blog. I'll link it in the show notes. Thanks for listening. I'll see you next time.